Hi, I'm Holly. I'm a first-year Ph.D. student here at the University of Illinois. I'm originally from California, and my bachelor's was in genetics and genomics, and so back then I got really interested in the intersection between genetics and human health, and so I found that agriculture was a nice intersection between those two interests, where we're able to breed for enhanced health-promoting properties in foods and also create more sustainable foods. So right now we're working on breeding for the maize microbiome so that we can reduce nitrogen losses and increase nitrogen uptake in maize production. So we know that modern domestication of maize has inadvertently bred against nitrogen retaining traits and has altered the maize microbiome. So we're asking, can we reintroduce ancestral genetics into modern maize and reintroduce those nitrogen retaining traits to create more sustainable food systems? This is a multi-university collaboration. It's been going on for about 5 years so far. And so yeah, this is my first year being on this project, so the 6th year of this. So we're looking at microbes in the soil because those are known to break down fertilizers and contribute to nitrate leaching, or nitrous oxide emissions. So basically N losses from the soil system. And right, we want to keep nitrogen in the soil so that the plant can take it up. And so that you're increasing your yield of your corn. So right now we're testing our most promising lines in a ground bed space, which is a more controlled environment than testing it out in the field. We're measuring soil for total potential nitrous oxide emissions, as well as measuring the actual magnitude of nitrous oxide emission using in-field measurements. And then we're also assessing whether or not the actual maize roots are interfacing with the microbiome through excreting compounds through that root tissue. We're taking soil cores, which is essentially digging up soil samples from the ground bed. We're going 15 centimeters deep, since that's where the majority of the microbial activity takes place. And then we're also collecting gas samples. So we're taking in-field gas measurements directly from the soil system.